Good morning. Today we're going to spend some more time on translations involving shrinkings and stretchings. Okay, consider a function defined by y equal f of x, and a represents a positive real number. Okay, so if you change y equal f of x to y equal a times f of x, it's the graph of y, it's the graph of this one stretched vertically by a factor of whatever a is. Now, stretched vertically, what do we mean? It comes in like this, it goes at a steeper angle. Okay, if it's just random points, then they're spread farther apart vertically. If it's a fraction, then the graph of that is shrunk vertically. If it's random points, then they're closer together vertically, and typically it will spread wider, but not necessarily. Okay, here's an example. If f of x equals 1/4 of x squared, remember x squared is a quadratic. It's going to be a parabola. Okay, so here plotting points. If you plot for 0, you get 0, 1, 1, 2, 4, 3, 9, and so on. And actually, these are plus or minus because they go on both sides. Okay, here we would get 1/4 of this one, 1/4 of this, 1/4 of this, and so on. And again, those are plus or minus because of the square. Now, instead of having a 1/4, we have a 4. Okay, there's the x squared again, same as here. And there's the 4x squared is g of x. Now, look at this graph. The black is just y equal x squared. Okay, the 1/4 is the blue, key to the color. Notice how this thing goes out flatter or shrunk. For this one, where it's 4 times, notice it goes out steeper or it's shrunk horizontally or stretched vertically. Those are kind of reciprocal functions. This one is shrunk vertically but stretched horizontally. Okay, here's another. If a is greater than 1, that means it's a positive number. This time, notice our notation is different. This time, the a is inside the parentheses instead of out front like it was before. Now, look what's going to happen. This is going to be shrunk horizontally. In other words, it's going to be steeper. Here, if it's a fraction, then this is going to be stretched horizontally, okay, or flattened. And again, we have our base curve here, and then this one is the fractional one. Now, this particular chart is probably something that would be well and good for you to make a picture of. However, this particular chart is in your book in the text. I don't remember the exact page number, but you can find this chart in your text, and it would be very good to make a copy of to have while you're working in ALEKS. It's a summarization of all of the different types of translations or shifts. Okay, going back to the other day, remember if we add something externally, it shifts it upwards or downwards. In other words, we replace the y value with y plus how much up or y minus how much down. Okay, if the number is inside a parentheses, inside a radical, inside a absolute values, then it's going to shift it left or right. Okay. Now, the shift left or right is opposite of sign. If you look, x minus 8 moves it to the right. X plus h moves it to the left. Always opposite of sign when your add-on is contained with the variable. Now, vertical shrink and stretch. We've got these two styles right here. Okay. For the vertical shrink and stretch, if A is a positive number, then you replace this with, you just multiply the y value by whatever A is. Okay. Now, if A is a fraction, if this A is a fraction like 1/2, for example, then you would have 1/2 A, or 1/2 times y. And that will either stretch or shrunk vertically by whatever A is. If it's A is a positive number, then it'll stretch it vertically. If it's a fraction, then it'll shrink it vertically. Okay, here's your format for horizontal stretch. Okay, if it's a positive number, now notice this one. This is the effect of shrink of horizontal stretch and shrink. Easy for me to say. Notice we are replacing the x in this case with the reciprocal of A. If it's a fraction, then I would have A times x. Okay, so the graph is shrunk or stretched by the reciprocal of whatever this A is. Okay. Now, a reflection, we're going to cover that in a little bit. We haven't covered it yet, so we don't need to worry about that bottom set. I know that this part can be confusing when they talk about horizontal stretches and shrinks. Vertical ones are pretty simple, okay? But the horizontal ones are, the language is just backwards to what you would think of. Okay, for example, we've got this, which translates, and here are your graphs. Okay, here you have your vertical shrink, you have your vertical stretch. Okay, look at this graph. Now, this is just a nonsensical function, f of x. Whatever the equation is, would generate these sets of piecemeal points that you would play dot to dot with. Okay. Now, so this is just kind of a fictitious equation, a non-continuous one. Now, if we had y equals f of 4x, what we're going to do is take all values times 1/4. So this point, which is -3, -1, would become -3/4. Okay, here. This point, you notice the y's are not changing. The x's are changing by the reciprocal of that 4 up there. So instead of this one being -1, then x would be -1/4. And here, instead of x being 4, it would be 1. And here, instead of x being 6, it would be 6/4, which is 2/3 or 3/2. So what that does is it shrinks this horizontally. Did not stretch it vertically. The y levels are still the same. They haven't changed, but this shrinks it horizontally. Here's my chart again. Okay, we got this thing right here, the horizontal stretch. We had a 4 for A in that last problem. So that says that we're going to change all the x values to x/4. Okay, here's another similar example. F of 2x is that equation with 2 greater than 1, or in other words, the graph of f of 2x is this. Now, what happened? The x value here is 1, 2, 3, 4. The x value here is 1, 2. In other words, half, or the reciprocal of 2, is 1/2. So you take half of whatever this one is to get that one. Half of whatever this one is to get that one. Half of whatever this one is to get this one. So this thing has shrunk horizontally. And this is just the language going over the explanation of that. I'll let you look at that for a second. And this one would be just the opposite. If it were f of 1/2 x instead of f of 2x, like we've got up there, then all of these would be the reciprocal of 1/2 is 2/1. Okay, so we would multiply all of these original x values. Technically, we're dividing them by a half. But when you have a number divided by a fraction, you flip and multiply. Remember that from junior high, hopefully. And because when you do fractional division, you take the reciprocal of the denominator and multiply. So we would be taking -4 times 2/1 when we take that reciprocal, giving us the -8. -2 times 2/1. So this division is the same thing as multiplying by 2. Dividing by half, same as multiplying by 2. Okay, 2 problems. If this is just f of x by itself, plain, okay, then we plotted what the 3 points on it are. So to answer this, then our points, the reciprocal of 2 is 1/2, so we take a half times each one of these values, getting -2, -1, 0. On that one, the reciprocal of 1/2 is 2, so we take all of these times 2. Here's the graph of this one. Notice how this thing is shrinking horizontally. Okay, and in the case of this one, still the same height, but it's getting spread out, doubled in fact, its width, its original width. The reason this point didn't move is because its x is 0 right there. Again, here is the chart that I've put up twice already. Just reminding you that on this one, if you got to determine horizontal stretch and shrink, you use the reciprocal. Now we'll talk about reflections. Okay, we've got an equation, y = f of x. Now, to reflect across the x-axis, in other words, to reflect this way, what was up here is now down here. It's kind of like the two halves of a book are splitting a Christmas tree right down the middle. Okay, what was up here is now down here. Remember, if f of x is y, then negative f of x, or negative y equals the equation, in which case you would divide both sides by -1, which would change all the x values. Okay, basically what are you going to do? You're going to replace y with -y to make it simple. Now, what about a reflection across the y-axis? Okay, now we're going like this. What was here is here. Okay, in that case, x becomes -x. Simple example. You have a point here, reflect with regard to this axis to here. If this was 2, 4, then this would be -2, 4. Now, if you take this same point and reflect it here, this point would be 2, -4. Okay, so if we took this point reflected across the y-axis, the sign of the x value changes. We take this point reflected across the y-axis, the x-axis, then although the x stays the same, the y changes sign. And this is just saying what I just said. So let's look at some more examples. Okay, this is the base graph. Whatever equation would fit and make that graph. Okay. Here, this is the notation to say that we're changing the y value. This is the notation saying that we're changing the x value. Okay. So since we're changing the y value, what was up here is now going to be down here. So this would now look like that. 0, 0 would still be the same. Here, the x value would still be the same, but the y value would become, instead of positive, it would become negative. For that point, instead of it being up here, now it's down there. The y went from positive to negative. Okay? Now, I want to show you something, an equivalent of this. If f of x, the equation, or y, is equal to x squared, okay? You're going to have a graph like that. Now, on the other hand, if we find that notation, then that means negative y is equal to x squared. Well, we can't leave that. We have to divide both sides by -1. So we've got y equals negative x squared, and the graph of y equals negative x squared looks like that. Or in other words, this is reflected across the x-axis. Okay, what about this one? What are we doing? We're changing x to negative x. So although that point will remain the same, this one will come over here, that one will go over there, this one will come out here. Like so. But this notation really means you're changing the value of y to a negative. And then you have to divide both sides. And that'll cause it to flip across the x-axis. Okay, what does A do? What's it going to do? It's going to flip it across the x-axis. What is B going to do? It's going to flip it across the y-axis. What is A going to do? It's going to change all of the positive y's to negative y's, all of the negative y's to positive y's. What is B going to do? It's going to change the signs of the x's. Okay. Now, we're going to summarize these of all that we've had again. Here's this same chart, or a similar chart to what I've had up here. We talk about the shifts, left or right. If it's external, it makes it go up or down. Okay. For horizontal translation, if it's included inside parentheses, radicals, absolute value signs, for example, then it shifts left or right opposite of sign. Okay, if we're doing a vertical stretch or shrink, if this is a whole number, then basically it gets taller. If that's a fraction, it gets shorter, it shrinks. This one, a horizontal, it goes to the opposite. Another, or not the opposite, the reciprocal. So in other words, if this is a 5, you divide all of that by 5. If it's a 1/4, then you multiply everything by 4. In other words, that's how you change the x values, is multiplying by the reciprocal of that a. Okay, reflections we just talked about. Here's the notation that means that we're going to change the y values. F of x is y. So we're going to make all the y's opposite sign. This one is the notation showing we're going to change all the x's to opposite sign. Now, let's look at these. You're going to have some test problems on this kind of problem. I've got a graph up there, an equation up there. N of x equals negative 1/2 x minus 2 quantity squared plus 3. Now, I wish I had a stick because my arm's not long enough to point. But we've actually got 1 inside the parentheses. The 1/2 is 1. The negative itself is a flip. And the plus 3 is a shift up and down. So the minus 2 moves right to the 1/2 is going to compress it. The negative is going to flip it across the x-axis, and the 3 is then going to raise it up. So let's look what happens when we do this. Here's kind of a roadmap of what's going to happen. This one's going to shift it right. Then this one is going to make a vertical shrink, okay, because it's a fraction. Then the negative is going to reflect it over the x-axis. And then finally, we're going to shift up. So here's what happens with the original, in black here, equation. The negative 2 is going to move it 2 places to the right. Then we take that answer right here. This is the one from over there. Then we're going to take this times 1/2, which it flattens it or vertically shrinks it. Okay? What was here is now here. 1/2 is high for the same amount of x travel. So now we're going to take this graph, this red graph, which is here, and then we're going to flip it across the x-axis, which you can barely see going down here in this green. Then finally, we're going to take the plus 3. Here is our green one going down here that came from there. And that plus 3 is going to take this whole thing up 3 units. So you have to do that sequentially, inside out, okay? You start with whatever's in parentheses, radical or absolute value. Then you move next to it, then you move out from that. And then finally, any add-ons is your last step when you do these translations. And you will have tests both on the final and on my test on doing this sort of thing. Now, the test problem might require you to just answer like this. For example, if you've got this, what do each of these modifiers do? Well, this one moves it 2 to the right. This one moves it 1/2 as tall, or a vertical shrink. This one will flip it across the x-axis, and that one will shift it up 3 units. Your question could be in that format. Now, we got an absolute value. Here's what just absolute value of x looks like. Okay? You can see it written over there. This is the base graph. Now, what are we going to do to this graph? First, we're going to move it left 1, opposite of sign. Then we're going to make it twice as steep. And then we're going to move it down 3 places. So, Here's the original. Now we're going to move it over the one place. Okay, so they just went to the final answer. I want to put in some missing stuff. Okay. Right here, I'm going to move it one place to the left. So it now goes like this. There's boards right there that are uneven, is why that's hard to draw. So this is our second one. This one is the base. So now let's go to our next step. We're going to multiply by 2. And when we multiply by that 2, okay, although this point will stay the same, that point will double. Okay. And this point will also double. So this thing is now going to go at this angle, like that. Okay. Because this is positive, this thing got steeper. It shrunk horizontally and it stretched vertically in this case. Okay, so now our final step on this one is we got to move it down 3. So we take this purple one and move it down 1, 2, 3, and it now goes up like this. Notice this one's still at the same angle as that one. It just moved down. And you can see it drawn a little more neatly over here on the other one. Now, to me, it's awfully difficult for me to go to this in just one step without actually drawing the interim steps as I go. So you can do that however you wish. The white duct tape actually works pretty good. Okay, what about this one? We're going to move it to the right. Then we're going to make it 3 times taller. Then we're going to flip it upside down. And then we're going to move it down 4. What about this one? We're going to move it 3 left because that's a positive 3. We're going to flip it across the y-axis, that negative sign will. Then we're going to shrink it. Then we're going to flip it across the x-axis. So here's the basic one. Okay. So what happens in this thing? Okay, now A equals absolute value of x, or A times absolute value of x, or 4 absolute value of x. Okay, here's the y equal absolute value of x. Okay. Now, what about 4 times absolute value of x? What would our values be on that? Well, if x is 0, it's still going to be 0. So it's not going to change here. If x is positive 1, then 1 times 4 is 4, positive 4, and negative Well, now, if x is -4, then we would still have a +4 both ways. So in other words, if x is 1, then this is going to go up 1, 2, 3, 4. And if x is -1, 1, 2, 3, 4, like so. If x is +2, absolute value of 2 is 2 times 4 is 8. And we would get the plus value there. If x is -2, we would still get 2 times 4 is 8. So this is going to be 8 no matter whether the 2 is positive or negative. So here, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And those are supposed to be straight if I graphed it properly. 2, 8, out here. Like so. And this one should be a little more like that. Okay, so you can see what this 4 did. It vertically made this thing higher. It also made it stretch, or shrink rather, horizontally. Okay, in this case, we've got square root of x. Okay. And we want to do x -2. Well, we have the limitation that x has to be greater than or equal to 2 on that one. But I've got the values already plotted over here. Square root of x here starts at the origin. We got the point 1, 1. We got the point 1, 2, 3, 4, 2. We've got the point 3 or 9, which is out here somewhere, 3. And this thing's going to go out like that. Okay, that's what we would expect with the square root of x graph. Now, what about the x -2 graph? Okay, and by the way, why can't we have negatives? Again, because square root of a -x would give you a 0. Now, you can't see my chart down here, so I'm going to move it up here. X, Y, and this is actually, that's a different chart. And this is square root of x -2. Okay, so in this case, if x is 0, then we would get can't graph it. Okay, if x is 0, we'd get -2. If x is 1, we get I. We can't graph that. If x is 2, okay, remember I said that x had to be equal to 2 or bigger. If x is 2, I get square root of 0, which is 0. If x is 4, I'm picking nice numbers. 4 minus 2 is 2, and I would get square root of 2, which is 1.414. If I pick the square root of, if I pick 6, 6 minus 2 is 4, and I get 2. So let's graph that one. Can't graph these 2 points. I still stay at the original or starting point. Okay, if x is 4, 1, 2, 3, 4, then where I did have the point here, that's supposed to be over here just a little bit farther, about there. Okay, if I have x is 4, 1, 2, 3, 4, then my answer is 1.44. 1.44. Okay. If I have 6, then I've got 2. What if I've got 2 here? Then I've got 0. I skipped that one. And so here it goes. As you see, this thing has been shifted 2 places to the right. Now, by contrast, let's use this equation right here. Y equals square root of x minus 2. And make an XY table. Okay. In this case, x just has to be greater than or equal to 0. 0, 0. Excuse me. -2. Forgot about that. In other words, it's going to be this set of data with the y values of 2 less. Okay, so if x is 1, then we've got -1. If x is 4, then y is going to be 0. If x is 9, then y is going to be 1. And we can graph those points. So 0, -2, 1, -1, 4, 0, 1, 2, 3, 4, 0, and 9, 1. So I drew that purple one a little too steep. So you see the effect of inside, shift left or right, outside, shifts up or down. Here we have a parabola, the basic form, and our parabola in particular. Okay, I have the basic form parabola right here, y equal x squared. Now, this time instead of doing plotting points, I'm going to get that equation by transformations. Okay? Just like over here, I could have taken this graph and just shifted it 2 places and redrawn it. And here, I could have shifted it down 2 places and redrawn it instead of doing all this plotting points work. So that's what transformations do for us. So I don't have anything inside with the x squared. I've got the 2 on the outside, which is going to double all the y values. So this one's going to be a 2. It'll start here again. And this one's going to be at 2. Then if this one is going to be, instead of 4, it'll be at 8. And for x equals -2, it'll be at 8. So here is my graph of y equals 2x squared. Okay. Now for my graph with the -3 added. I move this point down 3, 1, 2, 3. I take this point and move it down 1, 2, 3. This one down 1, 2, 3. This one down 1, 2, 3. This one down 1, 2, 3. And so here goes my graph this time. Now, that's a whole lot easier than doing all these tables. This will be the last slide that I'm going to go over tonight, or today rather. Okay, in this case, we want to find a horizontal shrink of 3x or absolute value if y is 3x plus 3. Okay, then we're going to find f of 1/3 x or y equals absolute value of 1/3 plus 3. Okay, we've got the basic one, the one at the in black, you can see f of x. 3x goes up like that, steeper. 1/3 x flattens. Okay, on this one, a vertical shrink. Okay. The 1/3. Notice the 3 is out here, so I have to divide both sides of this equation by 3. So I get this 1/3 times that. So I've got absolute value of x. And I take it times 1/3, which flattens it out like this. And I've also moved it down 3, or down. Okay. And then here, we're moving it up 9. We could do this one. It's going to be a graph that's going to look like this. If you look at your type things, now what's going to happen? It's going to be shifted one place right and flipped across the y-axis. So the basic curve for y equals cube root of x, I'm going to do in black, is going to look like something like this. Okay? Now, cube root of negative x plus 1. Okay. That's going to shift it one place to the left. So instead of this being here, it's going to be here. So this thing's going to start and it's going to go like so. Now, this negative x is going to flip it across the y-axis. So in other words, I've got points here and I've got points here. Let's call this 2 and let's call this 2. I don't know that they are, but for the sake of making it flip, it would be easier if I could. Okay, this point's going to stay the same. This point's going to move over here. This point's going to move over here. So now it's going to go like that. Okay? Because you're flipping it. We're flipping this one, not the original one, but this one, across that y-axis. And that's where we're stopping for today, and tomorrow we'll deal with piecewise functions. So have a great day, and we'll see you tomorrow. If there are any questions, I'm going to turn off the recording.